Today I'll talk about unit conversion. So that is also one topic of process calculation for chemical engineering. Now last class I talked about different units for what different system. So now here that we need to remember what are the basic unit conversion. So here I am giving that different system as well as the quantity, physical quantity, like physical quantity length. So we know the SI unit is meter, MKS unit is meter, CGS unit we know cm, and FPS foot, right? So 1 meter in SI system, so in MKS system will be 1 meter, CGS system, so unit of length is that centimeter. Now how do you convert 1 meter to centimeter? So 1 meter is equal to 100 centimeter, and then so 1 meter is equal to 3.281 feet. So we have to remember, so 1 meter is equal to 3.281 feet. Then mass, so 1 kg is 100 grams, sorry 1000 grams, and FPS 2.205 pounds. So we have to remember time in the empty system, so that is second. Now speed we know that in SI unit in the meter per second, so 1 meter per second if we convert to centimeter per second, so we know 1 meter is equal to 100 centimeter, so 1 meter per second is equal to nothing but 100 centimeter per second. And if we convert 1 meter per second to FPS, so that will be 3.281 foot per second. Area, the unit is meter square, so 1 meter square if we convert, so that will be 10,000 centimeter square, because we know 1 meter is equal to 100 centimeter. So now 1 meter square means that 100 into 100 centimeter square, so that will be 10,000 centimeter square. And if we convert in FPS, so that will be 3.281 into 3.281, so that will be 10.764 ft square. That we can calculate. So volume is volume unit, SI unit is meter cube. So 1 meter cube is equal to 10 to the power 6 centimeter cube. We know 1 meter is equal to 100 centimeter. So 1 meter cube means here 100, 100 and 100. Okay, so that will be 10 to the power 6 centimeter cube. And in the FPS again, so in the FPS we know that 1 meter per second is equal to 3.281 feet per second, so we have to just cube, so that will give 335.315 feet cube. Now similarly force, energy and pressure we can do that. So 1 Newton is equal to 10 to the power 5 dyne, and if we convert LVF, so that is 0.225 LVF. Energy 1 joule, energy unit is joule, so in CGS 10 to the power 7 arc, so 1 joule is equal to 10 to the power 7 arc, and FPS 0.738 foot pound F. Pressure, we know that SI unit is pascal or Newton per meter square, CGS that is 1 bar, and FPS 0.00145 psi. So we have to by heart all this, because if you know, so we can do later that how to conversion happen, so we can easily understood. Okay, you can easily understand how to do that. Now similar, that speed we know, that force, so you have to by heart all this. So speed 1 meter per second, CGS 100 centimeter per second, force 1 Newton is equal to 10 to the power 5 dyne, energy 1 joule is equal to 10 to the power 7 arc, 1 pascal is 1 bar, 1 watt is equal to 10 to the power 7 arc per second. So we must know what are the SI unit and what are the CGS unit, and if we know the base unit, so we can also convert, and I'll show you how to convert all this. Okay, so electric charge 1 coulomb, so that will be 3 into 10 to the power 9, static coulomb 1 volt, 10 to the power 8 stat volt, magnetic field, frequency, temperature, so here that SI unit of temperature 0 degree centigrade, CGS 273.15 Kelvin. So now we can do the conversion. Next here, so I am giving the unit conversion example, Like let's convert length of 10 meter into other system. So SI, that SI international system of units, so that is 10 meter. Now we know in MKS the same unit 10 meter. Now 10 meter, how do you convert in CGS unit? So 1 meter is equal to 100 centimeter. So 10 meter nothing but 1000 centimeter. So that is 1000 centimeter. Now we know 1 meter is equal to 3.28084 feet. Okay, so 10 meter will be that foot. So we can do that. If we know the base unit, we can. So I told you that first table we have to do the we have to remember, and we have to do the by heart. Means if you remember everything, so we can convert easily. Now let's convert a mass of 5 kg to other system. So now here, so SI unit, international system unit, that is 5 kg, MKS that is 5 kg, and then CGS 5000 gram, and FPS that is pound, so 11.0231 pounds. So we can do that. We can, if we know that. So again here we know that what is the order, the mass. So 1 kg is equal to 2.205 L pound. So now 5 kg 5 into 2.02 something like that, that is 5 kg, this is pound. So 1 kg is equal to 2.02 pounds, something like that. So we can get, so 11.0231 pound. So now we can convert all this. So if you again we know the base unit conversion, basic unit conversion or base unit conversion, so we can easily convert any system. I mean we can convert the from one system to another system. Now here the temperature conversion. Now here different temperature scales are there: Celsius scale, Fahrenheit, Kelvin, Rankine, and Reaumur. So I am taking from this website BMX. So I am getting BMX. So now here we know that absolute zero is that in Celsius scale is minus 273.15 degrees centigrade, and freezing point of the water we know 0 degree centigrade, and room temperature something 21 degree centigrade, and boiling water, so that is 100 degree centigrade. Now in the Celsius scale, so you must remember that, so absolute 0 minus 273.15 degree centigrade, freezing point of water 0 degree centigrade, and boiling point of water is 100 degree centigrade. And Fahrenheit scale, that absolute 0 minus 49.67 degree Fahrenheit. So if you don't remember that, but you have to remember freezing point water in Fahrenheit scale, that is 32 degree Fahrenheit, and boiling point of water, that is 212 degree Fahrenheit. Now we can see later I'll show you how to convert from one scale to another scale. And the freezing point of water in Kelvin, so that is 273.15 Kelvin, and boiling point 373.15 K. In the Rankine scale, so again freezing point of water we have to remember 491.670 degree RA, that is Rankine, we can write degree RA, and boiling point of water is 671.67 RA. And boiling point of Reaumur scale, that absolute 0, freezing point of water is 0 RE, and boiling point of water is 80 degree RE. So we have to remember this, so then we can easily do the temperature conversion. Now here how do you calculate, how do you convert Fahrenheit to Celsius and Kelvin? So you remember degree centigrade, so is equal to m minus 32 into 5/9. How it will come? So that will that degree centigrade minus that freezing point of water, so that is 0 degree centigrade, then that boiling point of water, that is 100 degree minus freezing point of water, is equal to 0 degree Fahrenheit minus 32 degree Fahrenheit, means this freezing point, and 180 degree Fahrenheit minus, that is boiling point, minus 32 degree Fahrenheit, this freezing point. So from this equation we can get degree C is equal to m minus 32 into 5/9. So now here if we know Fahrenheit degree, we put that and we can get the degree centigrade. Similarly, how do you convert the degree Fahrenheit to Kelvin? So Kelvin is equal to first we can do that. First we have to convert degree centigrade and then Kelvin will be 273.15 plus degree centigrade. So that will be the easy, or otherwise we can remember K is equal to degree Fahrenheit minus 32 into 5 by 9 into 273 into 15. Similarly, Celsius to Fahrenheit. So degree Fahrenheit is equal to degree centigrade into 9 by 5 plus 32, and Kelvin degree centigrade plus 273 plus 0.15. So Kelvin to Fahrenheit and then Celsius. So degree Fahrenheit will be K minus 273.5. First we have to convert in degree Celsius and then into 9.5 plus 32. So we will get in Fahrenheit. And then degree centigrade from Kelvin to degree centigrade, K minus 273.15. So we will get degree Celsius. Similarly here, Fahrenheit to Reaumur to Fahrenheit, then Reaumur to Celsius, Celsius to Reaumur. So all these correlations are given. So you can remember, or you can formulate. Means if you know that here this picture, so you can formulate all this equation, because that scale minus freezing point of water divided by that scale, not that scale, that boiling point of water minus freezing point of water. Okay, so I'll write here. So how do you formulate this? So remember that formulation is like that. So first, that scale minus freezing point of water by boiling point of water minus freezing point of water is equal to that another scale minus freezing point of that scale, freezing point of water of that scale, again minus boiling point of water of that scale minus freezing point of water that scale. So we can do that by this way. We can formulate this formula. Otherwise we can remember this. Similarly, from Kelvin to Reaumur, so degree RE is equal to K minus 273.15 into 4 by 5. K is equal to degree RE 5 by 4 plus 273.5. So remember, or we can get from that scale. So if you remember this, that chart and this picture, we can easily formulate that. Okay, so nothing. So how do you formulate? Like again, I can go like degree centigrade minus that freezing point of water, so 0 degree centigrade, by so boiling point of water 100 degree minus that freezing point of water 0 degree centigrade. Now if we construct that RE, so that is the freezing point, so that scale degree RE minus 0 RE by freezing point boiling point 80 degree RE minus 0 degree RE. Now ultimately we will get degree centigrade by 100 is equal to degree RE by 80. So now degree centigrade will be degree RE into 100 by 80 means 10 by 8 or 5 by 4. So it will be like here, degree centigrade is equal to degree RE into 5 by 4. So that way we can formulate the equation. So here we can see that. So here centigrade to RE, yeah, so RE is equal to degree centigrade into 4 by 5. So I told you degree centigrade is equal to RE 5 by 4. So we can formulate, so very easy. And Kelvin to Rankine, so RE is equal to K into 9 by 5. So you have to remember by heart, or we can do from that picture. We can create the you can do the formulation. Next is pressure. So now we know the formula of pressure in a fluid at specific depth is given by pressure is equal to nothing but that P is equal to H into rho into G. So pressure is equal to height, density and acceleration due to gravity. Now at sea level, the standard atmospheric pressure is 1 atm. 1 atmosphere is equivalent to height of 760 millimeter of mercury. So you remember that a standard atmospheric pressure is equal to 760 millimeter of mercury mmHg in a barometer. This means that a column of mercury in a barometer with a height of 760 mm can support the same pressure as the atmospheric at the sea level. Means 1 atm pressure is equal to 760 mmHg. Now if we convert 760 mm to cm, that is 76 cm Hg. And if you convert cm to meter, so that is 0.76 meter Hg. Now we know that P is equal to height into density into acceleration due to gravity. So here height is Hg height, density means Hg density and acceleration due to gravity. Now here Hg height is 0.76 meter and density is 13,600 kg per meter cube and acceleration due to gravity is 9.81 or 9.80 meter per second. So if you do the calculation, we will get that 101,396.16 kg meter second square by 1 by meter cube, not meter cube. So meter will cancel, so that will be meter square. So that will be, so 1 kg meter per second square is nothing but a Newton. So Newton per meter square is actually Pascal. So now, so 1 atmospheric pressure is equal to 101,396.16 Pa. Now there is slight difference. So you can see here 1 atm is equal to 101.325 kPa. Remember that. And 1 atm is equal to 760 mmHg. Another unit is there that is called torr. So 1 atm is equal to 760 torr. So remember this. So that will help to convert from one unit to another unit. So remember 1 atm is equal to 760 mmHg, 1 atm is equal to 760 torr and 1 atm is equal to 101.325 kilopascal. So remember that that 1 atm is equal to 101.325 kilopascal. So now I will already show you. So 1 atm is equal to that 101,396 pascal. Now if you do that, so that will be 101,325. Slightly different because if you take that G is 9.81, so there will be some difference. And if you take the accurate value, so that 1 atm will be so 101.325 kilopascal. Now here I am giving one example. So convert 760 mmHg to atm. Now we know that 1 atm is equal to 760 mmHg. So 760 mmHg is equal to 1 atm. So pressure in mmHg by 760 mmHg, 760 mmHg given, that is 760 mmHg by 760, that is 1 atm. Means 760 mmHg is equal to 1 atm. Now convert 760 mm is torr. So we know since 1 atm is equal to 760 torr, so we know pressure in torr means pressure in mmHg. Pressure in torr is equal to 760 mmHg, 760 torr. So 760 mmHg equal to 760 torr. Convert 760 mmHg to kilopascal. So pressure in kilopascal is pressure in atm into 101,325 kilopascal. So pressure in kilopascal, so 1 atm into 101 into 325 kilopascal. So pressure in kilopascal will be 101,325 kilopascal. So 760 mmHg is equal to 101,325 kilopascal. So remember that. Now units of force in different system. So the formulation of force is given by force is equal to mass into acceleration. So force unit is Newton. So 1 Newton means 1 kg into 1 meter per second. Mass is 1 kg, acceleration 1 meter per second square. So unit of force is Newton. Means 1 Newton is the force required to accelerate a mass of 1 kilogram at a rate of 1 meter per second squared. So 1 Newton is nothing but 1 kg meter per second square. So the definition is 1 Newton is the force required to accelerate a mass of 1 kilogram at a rate of 1 meter per second squared. So remember that. So that is the international system. So Newton means 1 kg into 1 meter per second square. Now MKS system. MK system, the unit of force is kilopond or kilogram force here. So remember here that force is nothing but in MK system mass into acceleration due to gravity. So now here we are taking acceleration, that is 1 meter per second square. Now here acceleration we have to consider 9.81 meter per second, means 1 kilogram force is indeed defined as force required to accelerate a mass of 1 kilogram at a rate of 9.81 meter per second square. So remember that. So force in M case, so that is mass into acceleration into due to gravity. So force is like F is equal to m into g. M is 1 kilogram and g is 9.8 meter per second. So 1 kgf is nothing but 9.80665 newton approximately, or 1 kgf is equal to 9.81 newton. Remember that. Now coming to the CGS system. So unit of force is here dyne. So 1 dyne is the force required to accelerate a mass of 1 gram at a rate of 1 centimeter per second square. So force is nothing but mass into acceleration. So we know 1 newton is equal to 1 kg into 1 meter per second. So if we convert that 1 kg is 1000 gram and 1 meter is 100 centimeter. So 1 newton will be 10 to the power 5 gram centimeter per second square. So the gram centimeter second square is nothing but dyne. So 1 dyne is equal to 1 gram centimeter second square, that is equal to 10 to the power 5 newton, or 10 to the power 5, 1 newton is equal to 10 to the power 5 dyne, or 1 dyne is equal to 10 to the power minus 5 newton. Remember that. It is required, means it is frequently come when we do some unit conversion. Now again the unit of force in FPS systems, foot pounds second system. So force is mass into acceleration due to gravity. So 1 lbf in that FPS system, that foot pound second. So 1 lbf, so that is 1 pound into 32.17 foot per second square. Now if you do that, so that will be 32.174 lb/ft per second square. So now 1 pound, you know, that is equal to 0.4535923 kilogram, and 1 foot is equal to 0.3048 meters. Now we can, if we convert 1 lbf into newton, so that will be 4.4482 newton. Now here unit of force is the pound force. What is the definition in FPS system? 1 pound force is the force required to accelerate a mass of 1 pound at a rate of 32.174 feet per second squared due to gravity on the surface of the earth. So relation is here, 1 lbf is equal to 4.44829 approximately. That is 1 lbf is equal to 4.44 newton approximately. Now coming to the units of acceleration due to gravity in different system. So SI unit, you know, the gravity meter per second square, and we know that G is 9.81 meter per second square. Now MK system, same thing. CGS, so that is, it is acceleration is called gal, or you can say G is equal to 980 semi per second square. And for foot pound second, so G is actually 32.174 foot per second square. Remember that. Now units of work in different system. So unit of work SI system is joule, and 1 joule is equal to actually 1 in newton or meter, means work, you know, work is equal to F, force into displacement D, so newton and meter. So 1 newton meter, and 1 newton meter means 1 newton is equal to 1 kg meter second square into meter, so 1 kg meter square second square. So MK is also same. CGS, that is arc, so 1 arc is equal to 1 dyne centimeter, 1 gram centimeter square per second square, and 1 arc is equal to 10 to the power minus 7 joule. Remember that. Unit of work in FPS, so foot pound FTLB, so 1 FTLB is equal to 1.35582 joule, and we can convert that, we will get that. So 1 FTLB is equal to FTLB F, so that is 1.35582 newton meter. Now units of power in the system. So unit of power is watt. So 1 watt means power unit, means work per time, means joule per second. So watt is equal to joule per second. Joule per second, or 1 joule is equal to Newton meter, 1 Newton meter and per second, so 1 kg meter square second cube. Then SI unit watt, numerical value 1 watt. So again same thing, MKS same thing. So CGS, so that is arc per second. So 1 arc per second is equal to 10 to the power minus 7 watt. 1 arc per second is equal to 1 dyne centimeter second is equal to 1 gram centimeter square second cube. And then foot pound per second, that is force. So that will be 1 ft lb per second is equal to 1.35582 Newton meter per second. And remember, power 1 horsepower, 1 HP is approximately equal to 746 watt. So 1 HP is equal to 746 watt. Remember that. And always remember the base unit. Okay, so in that first slide, if you remember, so you can easily convert. If you know what is power, what is work done, what is force, what is pressure, if you know that, so from if you know that formulation, so from that formulation you can easily do the conversion. So one unit to another unit. So that's it. So if you have any queries, so you can send message or you can email. That's it. Thank you.